Now, it should come with no surprise that there exist an infinite amount of natural numbers, numbers like 1, 2, 3, and so on. They're also called countable numbers. But how many numbers exist between 0 and 1? Looking at the number line, it should be way bigger than the tiny segment from 0 to 1, but this is not true at all. Let's look at the x and y plane of all positive numbers in the form of ordered pairs, 1, 1, 2, 1, 3, 1, and so on. Compared to the number line, this looks a lot bigger as well. However, if we start to connect the points, we begin to form the number line. Okay, so the amount of all positive numbers on a plane is the same amount as on the number line. No surprise there. Now, let's draw a line with slope of 1 on the plane. This line will represent the number 1 as it goes through all ordered pairs which equal to 1. Therefore, all numbers above it are greater than 1, like 2, 10, million, all the way to infinity. But that means that all numbers below this line are from 0 to 1, like 1/2, 1/5, and 1/millionth, and so on. And we can draw lines through each point. And an infinite amount of time later, all points will have a line going through it. Thus, there will be the same number of lines above and below 1. Let's put this visual example into mathematical terms of sets and make them equivalent. We can easily make the set from 1 to infinity by just listing all the natural numbers from 1 to infinity. We're going to call this set n. To list numbers from 0 to 1, we can start with 0, then go to 1/2, then 1/3, 2/3, 1/4, 3/4, 1/5, and so on. We'll call this set R. And at the end of set R, 1 should exist. Now, in math, to make things equal to each other, we use the method of Gregor-Cantor, putting things into a one-to-one correspondence with each other. 2 plus 2 equals 4. So, we start to connect the two sets. And we do this infinitely. But because the sets are paired with each other infinitely, to which number can we pair 1 to? For this, we use the solution to the Hilbert's paradox of the Grand Hotel. The paradox asks the question, if there are an infinite amount of rooms in a hotel and all rooms are booked, how can we add one more person in? Well, we just shift all the people to the next room. 1 goes to 2, 2 goes to 3, and so on. And because there are an infinite amount of rooms, we can always make more, thus vacating a room for this person. We apply the same method here. We simply count down from 1 instead. This makes both sets into a one-to-one correspondence with each other, making them equivalent to each other. Therefore, there exists an infinity between 0 and 1, which is the same size as 1 to infinity.